Hello. Today I'd like to talk to you about the elementary periodic table, a simple look at the periodic table for those of us who have seen chemistry before and want to practice some of those skills that are essential to understanding the periodic table. We're going to be able to identify an element as a metal or a nonmetal. We want to be able to identify some of the major oxidation states of an element in a compound based on its position in the periodic table and identify those number of valence electrons in it. And then finally, the major skill we want to be able to have is to predict the ratio of two elements when they combine to form a binary molecular or ionic compound. For example, NaCl versus CaCl2. We want to do this based on those oxidation states that we know. So taking a look at the modern periodic table here, the first thing we want to be able to do is see, okay, where generally are metals in the periodic table and where generally are the nonmetals. You might recall that there's a stair-step line that you can kind of draw on the periodic table to separate the metals from the nonmetals, and we're going to start it right here between boron and aluminum. You start there, draw on down, and that's where I'm going to separate my metals from my nonmetals. My metals are going to tend to be on the bottom left side of the periodic table, whereas my nonmetals are going to tend to be on the top right side of my periodic table. Now in the middle, you're going to have your metalloids or your semimetals, which are going to have properties of both metals and nonmetals, but we're not going to discuss those today. Now, one additional thing you want to know about metals versus nonmetals is the type of compounds they tend to form. Metals, when combined with themselves, tend to form metallic compounds. Compounds that have certain properties like high conductivity of both electricity and heat. They tend to be malleable, ductile, and properties like that. If they combine with a nonmetal, however, they tend to form ionic compounds, which have another set of properties. They can be soluble or insoluble in water, depending on certain properties. They can conduct electricity in solution with water, but not by themselves. They have high melting points and such. Whereas nonmetals, by themselves, tend to form molecular compounds or covalent compounds. They're covalently bonded together to form molecules, which are sets of atoms that are bonded together in a group, which is different than how ionic compounds or metallic compounds exist. Now, speaking of metals and nonmetals, there's one other way that we want to be able to identify elements in the periodic table, and that's based on their group. Now, we're not going to get into group names or anything at this point in the course, but one thing you do want to be able to identify is that every group, elements in a group of the periodic table, which are the columns that we have, groups have similar chemical properties. And you might recall that groups have these similar chemical properties because they have the same number of valence electrons. And so because they have the same number of valence electrons, they tend to have the same oxidation state. When forming chemical compounds. And so let's kind of review what some of those oxidation states, those major oxidation states you might have for certain groups. Now, you do not need to memorize the oxidation states of every element on the periodic table, but there are some general ones that you're going to want to know. The first have to do with these first two groups of metals. We're going to ignore hydrogen at the moment, but for these first group of metals, everyone in group 1 is going to tend to have a +1 oxidation state when forming a chemical compound. So if I look at the chemical compound NaCl, I can remember that Na is going to have a +1 oxidation state. And that helps me because that helps me know the chlorine here has a -1 oxidation state. Now, those in group 2, they have 2 valence electrons, and so they're going to tend to lose both of those and form a +2 oxidation state. That helps me make predictions. If I wanted to know what a calcium ion would do when combined with a chlorine, it's not going to combine in a 1-to-1 ratio like a sodium chloride. It's going to form CaCl2 because calcium likes to be +2, and like we just saw in the compound above, chlorine is going to tend to have a -1 oxidation state. Moving onward then, over on the right side for my nonmetals, and this is just for the nonmetals only. This does not describe the metals down here, but if you're in the group 17 here, these are going to tend to have a -1 oxidation state, like we saw over here with chlorine. Our noble gases are going to tend to have no oxidation state. They're not going to want to form chemical compounds. Ones in group 16 here, like oxygen, -2, and in group 15 with nitrogen are going to tend to form -3. And these are generally the oxidation states you're going to want to be familiar with. Now, one thing, there are 3 metals that you can nearly always know the oxidation state of, and they're very common metals to use in AP chemistry. So let's go over those real quick. They are silver, which takes a +1 oxidation state, zinc, which takes a +2 oxidation state, and aluminum, which takes a +3 oxidation state. It's nice because they form kind of a series here as you go diagonal up there with +1, +2, and +3. So now hopefully you can use these general oxidation states to make predictions about what form a chemical compound would take. For example, aluminum oxide we know is going to be a mixture of aluminum with a +3 oxidation state and oxygen with a -2. To get 3 and 2 to combine in a whole number ratio, we're going to need 2 aluminums and 3 oxygens. So I can make that prediction. Okay, hopefully now you can identify metals and nonmetals in the periodic table. You can identify what kind of compound they're going to form, whether it's ionic, metallic, or a molecular compound. You can hopefully predict major oxidation states, and then finally use that prediction to predict the form of a binary compound. Thank you all. Have a fantastic day.